Hello, I'm David Black. The first video in this series was an overview of my dissertation research, its theoretical foundations, and intended outcomes. Now, a deeper explanation is required. I need to explain my vision of what is possible through student-created science media projects, along with the goals and characteristics of excellent project-based learning, or PBL.
PBL Works, formerly the Buck Institute for Education, lists 7 characteristics of gold standard project-based learning. These are 1. Providing students with a compelling problem or question to explore, which they have a decent opportunity to answer. 2. Giving the time and support students need for extended inquiry and experimentation. 3. Authenticity, or a challenge that is meaningful and relevant to their lives and requires the use of real data and real-world experience. 4. Student voice and choice in how to approach the question or problem. My dissertation claims that this should include the choice of which medium they use to demonstrate mastery. Instead of teachers choosing for all the students to create a video or a poster or a skit, the choice of medium should be left to the students, who receive the software training they need through online videos. 5. The opportunity for formative critique and revision, often through peer evaluations that are kind, specific, and useful. 6. A public presentation of the final product or media created, with audience feedback. And 7. Opportunities for reflection and improvement throughout the process, including metacognitive analyses of how and what students have learned through their projects.
I've had the privilege of mentoring students through a number of projects that meet these requirements and which have led to deeper learning of science concepts. You can check out these projects at my blog site under the description below.
Some have required my students to access and analyze authentic NASA datasets or gather field research data, draw conclusions, and present their findings at scientific conferences through posters. Other projects have asked my students to create educational media, such as documentary videos, books, newsletters, or interactive programs, build models, and design solutions to problems.
Currently, I'm working to bring project-based learning and authentic scientific research to a private school here in Utah.
In addition to small-scale projects for each unit of our science classes, students are expected to develop individual science or engineering research projects for the regional science fair, and to develop group projects that reach out into the community to solve problems, educate others, and make a positive contribution to the world. Every Friday, the entire high school meets together in our Innovation Lab program to implement these projects. They reach out to businesses and organizations in the community, look at large-scale educational or environmental needs, and develop solutions. These projects involve teams of 4 to 5 students each, completing up to 8 different projects this school year.
Let me walk you through a hypothetical project that will show you the vision of what is possible through project-based learning.
Let's say that a group of students contacts a local museum, say the Museum of Ancient Life at Thanksgiving Point. They work with personnel at the museum to assess a need, which is to incorporate additional information and interactivity into the exhibit displays without requiring more signage or huge expense. Upon brainstorming possible solutions and determining the best one, the students decide to add a series of QR codes to the existing displays that, when scanned, bring up additional information including text, images, videos, interactive puzzles and games, scavenger hunts, and even augmented reality scenes. They decide to prototype this system in one room of the museum. During September and October, the students learn and practice the software and project management skills they will need, such as asset management, leadership, 3D modeling, photography, image design, 3D printing, communication, and creativity. They use these newfound skills to create all of the pieces of their user experience. As just one example, they'll need to learn how to create 3D models of dinosaurs in programs such as Blender or SculptGL, add textures, rig and animate them in Adobe Mixamo, and then program triggers and actions in the augmented reality scenes inside Adobe Aero. By the end of October, the projects are decided and well underway. During November and December, team members take on individual assignments to research and photograph each display, and then use their software skills to create the pieces, which are put together into PDF documents, websites, YouTube videos, and augmented reality scenes by January. The team conducts alpha testing in-house with QR codes in late January and early February. Students on other teams try out the system and make recommendations, starting with small-scale 3D prints of the exhibits, or perhaps even on-site in the museum after hours. In late February, the project is improved and communication pieces built, such as display backboards, additional text and signage like charts, graphs, music, narration, websites, videos, and so on, and then everything is assembled and practiced. By March, the project is displayed and tested during school by elementary and middle school students and their teachers as our school science fair. If the project is judged to be one of the best ones, it is sent on to the Central Utah STEM Fair at Brigham Young University for judging in mid-March. If it goes on to win a sweepstakes award at CUSUF, it will go on to the International Science and Engineering Fair in Dallas in May of 2023. All projects will be presented at our back-to-school STEAM Showcase Night, along with additional student science demonstrations to be held on April 27, 2023. All student projects will be described and posted online through my blog sites and the school website. A final meeting with representatives of all stakeholder groups, including museum personnel and marketers, press representatives, target audience members, and others, will be set up in the middle of May to test the final version on-site in the museum. Students will receive final feedback from the audience and then reflect on what and how they have learned by the last week of school. This is just one hypothetical example of a possible student project. For other examples of what is possible, a great source is the High-Tech High system of schools in the San Diego area. They have implemented a system-wide project-based learning community that has developed dozens of high-quality student projects. These projects have been summarized in a series of project cards on the High-Tech High website and magazine. Let's look at a few of them. In the Apocalypto Project, a physics teacher teamed up with a world history teacher to build a vast machine. Using a laser cutter, teams of students cut out gears and other simple machines to create a wedge section that demonstrated the rise and fall of a civilization, shown through the operation of motors, pulleys, gears, levers, and other machine parts. Each wedge was attached to a large master gear driven by a motor. This project was featured in the documentary Most Likely to Succeed. In the DNA barcoding project, a biotechnology teacher teamed up with the Southwest Division of the U.S. Navy to study, tag, and develop DNA barcodes for invasive species in San Diego Bay. They wanted to monitor the ecological shifts caused by these invaders, such as benthic marine invertebrates. By identifying the spread of these species through early detection, the invaders can be eradicated before they cause large-scale ecological damage. The project identified 8 invasive species in the bay that had not been detected before. In the Physics A to Z project, students identified 26 different concepts in physics, each starting with a letter from A to Z, and created a series of informational pages for a book with text, student-created graphics, and layout design. Students then researched their topic, wrote up the text, which went through several revisions, and then created their own illustrations using SketchUp, Photoshop, Illustrator, and even hand-painted watercolors. The pages were laid out in Adobe InDesign, and the final book published online. In the Chemistry and Conflict project, chemistry students learned how to do copper etchings, then teamed with a humanities teacher to research how various chemicals and elements are related to world conflicts, such as blood diamonds and the mining of cobalt in the Congo through slave labor. Each story was illustrated through copper etchings and written into chapters of a book through several revisions. The entire book was then published online. These are just a few projects created at High Tech High. There are many more examples which I encourage you to take a look at. The possibilities are endless.
I won't deny that this is an ambitious idea. It's going to push the boundaries of everything you're capable of as students. But in the process, you're going to learn some new skills and new capabilities that you didn't even have before. It's going to give you greater self-assurance and greater confidence as students. It's going to give you marketable skills. And in the end, it has the potential for you to truly make a difference in the world. Learning is never easy, but it's always worth it.
I have seen students rise to this level of challenge before and complete some remarkable projects. Everything from presenting scientific posters at professional conferences to creating a 2-hour documentary on the history of AM radio in Utah for Salt Lake City's PBS station.
You are every bit as brilliant and capable as those students. I look forward to seeing what you come up with. It's going to be amazing. Thank you for listening and keep on learning.